Hi, I'm Obscure Byte. Welcome back. Today, we will looking at the Raspberry Pi 5. It is a compact single-board computer, but it's built for really products, coding, robotics, home servers, and even light desktops. Raspberry Pi 5 uses a 2.5 GHz quad-core 64-bit ARM Cortex A76 GPU and a Radeon 7 GPU. So it is a big setup for all the models. It also supports dual 4K and 60 Hz display output, plus fast USB 3, so you can actually build a pretty typical setup with a board this small. So what is the Raspberry Pi 5? In one sentence, it is a full computer trunk onto a single board, decided to be affordable, hangable, and powerful enough for daily projects. Unlike a microcontroller, the Pi 5 runs a full operating system like Raspberry Pi OS. The generation uses a 2.4 GHz quad-core Cortex A76 CPU and a Radeon 7 GPU, so it feels much more like a real desktop than older models. You get modern connectivity too. Your 4K 6PFS HDMI output, Wi-Fi 8.0 2.11 AC, Bluetooth 5, digital ETH, and both USB 3 and USB 2 ports. And it even has PCIe, which means you can add fast prefers like using a M.2 SSD and adapter. So who is it for? First, students and beginners, because you can learn Linux, Python, and electronics with really hard work. Second, makers, for sensors, robots, small home projects, and DIY devices. Second, power users. The Pi 5 now supports up to 16 GB RAM, so lightweight development and multitasking are totally realistic. Fourth, home level and server people. Think tiny web servers, NAS experiments, AD-Log DNS, and server hosted tools. In short, Raspberry Pi 5 is great if you want one small board that can be a desktop, a controller, and a server, depending on what you install. Next, I will show you what's on the board and how the ports work, so you can choose the right setup for your own projects. Raspberry Pi 5 gives you a really practical I/O layout. 2 USB 3 ports and 2 USB 2 ports. So I usually plug the SSD into USB 3 and keep USB 2 for keyboard, mouse, or low-speed devices. And if you want to go beyond USB storage, Pi 5 also exposes a PCIe 2 X1 interface with an adapter like the Raspberry Pi M.2 HAT ports. You can connect NVMe drivers with peak transfer up around 500 MB. I'm not using NVMe in this setup today, but it's really nice update pass. About displays, I don't have a 4K motor there, but it's worth noting that version 5.5 supports dual micro HDMI output up to 4K P60, even on a normal monitor. The dual display support is great for multitasking, like coding on one screen and documentation on the others. This is the display, and I use XFCE desktop. Now, okay, let's do something participate.
This silly crypt script tends to tie into a live system motto, temperature, CPU, frequency, and memory usage in real time. It's a great way to understand performance and camera behavior while you're running ready workloads. Import CIMD. What? Mm-hmm. I hope it can run over. What? See? Oh? What's inside it? Okay. Very good. Very good. Oh?
That's probably something wrong. But now it can run normally. So that's my Raspberry Pi 5 setup, and why it is generally useful, not just a tool. In the next video, I want to build a real project on top of it, either a sensor dashboard, a tiny home service, or a automation setup.